give them more money.
Oh yeah. Well, that was always going to happen. The question was how much. That was the question. So they were offered 8%. They wanted 15%. So no surprise that in the end they got 11%. Yeah, in the middle. Yeah, exactly. So like, I mean, you know, that's the way things go in life. Okay. So do you have the question to read there? What's the first one from the weight homework? Yeah, do you have it, Andy, or does anyone have it? The weight homework?
60 kilograms.
Okay, there you go, right, sorry, go ahead, 60 kg.
Yeah, diver jumps from a plane.
Yeah.
First question, approximately how long until he reaches the speed of 56 ms per minute?
Okay.
1.
So there's the plane. There he is jumping. And he starts at rest. What's the V? 60, is it? 56. The A, no, actually, I suppose I should say the B is minus 56 because he's going down. The A is minus 9.81, and the T and the S we don't know. And what did I want? The T, was it?
Yeah.
Okay, well, this is usual. Yeah. So what's the formula we'll use?
For what? For T?
T.
V over
no.
It's V over speed. Speed.
Distance. No.
Yeah.
Yep. We have fancier formulas than that. Yeah. V equals U plus AT. Do you know this formula?
Yeah. But what's U?
Zero.
The initial velocity.
The start speed.
And UF. The final speed.
No, we don't use UF. We use no. We listen. I know what you're saying. I understand you. So we don't use UF or UI, UF or anything. We use U and V. This is the start and this is the end. Okay. All right. We're good. Right. Right. So V equals U plus AT. So the T is, what's that now? 6.1 seconds, is it? Hey, okay, yeah. So we're doing the second homework first, the one on the weight, okay?
5.7.
Oh, guys. It is 5.7, Adnan. How did you get that wrong? 5.71. Did you type it in wrong? Yeah, maybe, okay. Right, what's the next part then? This has multi-parts, doesn't it?
Yeah. The skydiver opens his parachute and decreases his speed to 1 ms minus 1 over a period of 6 seconds. What was the average approximate drive force during those 6 seconds?
Okay, so what happens here if you look? The skydiver is going at 56 meters per second, and then he's going at, what do you say, 1, was it?
Yes.
1 meter per second. So what happens to his velocity? It's changing, so therefore there's an acceleration from a force. Yeah. So what's happening is when he starts to open the parachute acts like a force, a drag force. It's going to push upward, so to speak. So you know what it looks like. So anyways, I asked for the acceleration. So what else do I give you? Did I give you the time? I must give you the time. 6 seconds to go from here to here. So we have U, V and T. Yeah, so again, yeah, we can just use V equals U plus AT.
So this is the average approximate drive force?
No, we're working to that. It'll take a couple of steps. So we get minus 1 equals minus 56 plus 6A. Yeah? So what's that? 55 equals 6A. So A is 55 divided by 6, which is 9.17. Now why is this positive?
Because both are negative, that's why.
I know, but physically, what's the reason for the positive?
It's going down and then it is going up.
Oh, this is already okay. Is that okay? Can you see that?
Yeah.
Mr. Steve,
Yes.
can you repeat the question? For what? Why positive?
Yeah, why is the A positive?
When it's coming down, then it opens the parachute, then it's going up to the
Maybe because
when it's going up, that will be positive.
maybe
Yeah.
because this is the
Like
the velocity of the parachute because it's pushing up. Maybe.
maybe.
Okay, it's okay. Just listen. You're making it much more difficult than it needs to be. Down is negative and up is positive. Okay. So what's happening is speed is negative, but it's less negative here. The acceleration is positive because you're going from you're getting an upward acceleration to try and cancel the negative. So you see, he's going minus 56. Now he's going only minus 1. So the acceleration must be opposite to this
Yeah.
because
Is it because of the drag?
yeah, it's from the drag. Yeah.
Okay.
Which is what we're calculating, alright? So, next part. What are the two forces acting on our man? Yes, two forces. What are they?
Drag force and thrust.
Gravity and drag force, the thrust force. So, here it will be F, I'll call it D for drag, and here it will be the weight. Yep. So what is the man's total force? It'll be
60 multiplied by 9.17.
yeah, well, the total force actually will be,
Minus, yeah.
yeah, well, I'll do it the other way. The FD minus the W. That's the total because it's
Yeah.
this minus this. Yeah. When the parachute is opening. Yeah. Now, here's an interesting question. Which is bigger, FD or W? Or, yes. Because when he opens the parachute, temporarily the FD will be bigger to slow him down. There'll be an upward force.
Because the weight is like getting slow.
The weight stays the same, but the FD is bigger. So what's happening, and it's important that you picture this. When he's falling at first, he has only W. Then when he opens the parachute, while the parachute is opening, he has a FD. But this FD will be bigger than the W.
That's why when you open parachutes, you slightly go up at first.
It looks
You
like
don't
you're
go
going, you don't go up, it looks like you're going up. In fact, what's happening is you're just slowing down. So what'll happen is you'll slow down, but you won't continue to slow down, will you? At some point you'll reach a steady speed. At this point, what is the relationship between the forces?
They're the same equal.
They'll be equal, yeah. Because then he's moving at constant speed, no more acceleration because no more force. Yeah.
So, acceleration is 0.
Acceleration is
The
0.
constant speed, like 5.
Yes,
5, acceleration 0.
yes. So like here, acceleration is, speed is 1, so here the acceleration is 0.
Yeah.
But not for these 6 seconds, is definitely not 0 because he's slowing down. Yeah. Okay, so we know the formula for F, very easy, MA, so that'll be 60 times 9.17 equals FD minus mg. So here we go. It'll be 60 9.17 plus 60 9.81. One three nine. Yeah, we'll say
Yeah.
newtons. Is that the last part or is that the third part?
There is a
Oh yeah, what's this?
Will his drag force stay the same as in?
Yeah, okay. Well, we kind of said that already. No. What will happen is the FD will eventually balance with the W, but this will happen after the 6 seconds. So he doesn't continue to slow down.
But the answer that I got in the calculator is 1138.8. So I make it 1139.
Yeah. For 4 digits is good. Yeah.
Only 5, yes?
No need. You won't lose marks if you did 5. 4 is enough.
Okay.
Okay.
Number two.
That's okay for number one, is it? We'll go on to number two?
Yeah.
Okay. Right, number two, what's happening?
A bullet is shot vertically upward
Yeah?
at a speed of 300 meters ms minus 1.
Yeah.
The terminal velocity of a free-falling bullet is 150 ms minus 1. Approximately how long until the bullet strikes the ground? Hence, ignore the drag force term until terminal velocity is reached.
Okay, fair enough. So what's happening here? If you can picture it like this, the bullet is fired up in the air. It will go up, it will slow down
Zero.
to zero,
Yeah.
and then it will
Come
fall
down.
back down.
Come down.
Okay. Now, what's going to happen roughly, is this will start off with 300.
So the final final speed is zero.
This is zero here. Yes. That's the V, and that's the first half. Yeah.
No, MS.
MS?
Mile.
Mile? Goodness, no. What's? Tell them what this is.
Meter per second.
Meter per second.
Meter per second.
Yeah, but
But what? Oh, you see, he wrote down this. And
oh, it's
No,
yeah,
the same.
it's the same. But we said in the first class, actually, we don't do it like this. We do it like this. Yeah. You should watch my YouTube channel. You can watch the video for this. Right, okay.
What's the name of the YouTube?
This is under units and dimensions, this one, about the MS. Okay, so let's get the time to get to the top. The U, 300. The V, 0. The A, minus 9.81. And that's enough information, isn't it? What formula to use, though?
V equals U plus A T. No.
Yeah, no, that's
Yeah.
V equals U plus A T. Okay, I think I made this bullet too fast. Because it's like 30 seconds.
Zero.
Yeah.
V equals zero.
Yeah. This is the formula V equals U plus AT. Okay, so here I get T is 30.6 seconds. That's too fast. I made my bullet too fast. It doesn't matter. Okay, so now what happens? The bullet starts to fall down.
So the U is 150? No.
The U is 0.
And the V is 150.
Yes, the U is 0, the V is 150. So at some point as it falls, the V will become minus 150.
Yeah.
But then it keeps that for the rest of the fall, because this is its terminal velocity.
Maximum.
Final.
Maximum,
Yeah.
yeah. Not necessarily, well, final I suppose true, but maximum velocity. So let's work out the time to get to the maximum velocity. So again, the same story, V equals U plus AT. So we have 150 equals 0, minus 150 equals 0, minus 9.81 T. So here the T is 150 divided by 9.81. So here this is 15.29. Yeah.
Right. Thank God.
And then for the last part, it's just, is there any acceleration? No. So we can just use our triangle, distance, speed, and time. So if I want the time, that's the distance over the speed. So the time will be the distance over the speed. And now you realize, oh, I don't know what the distance is. So now you have to work out the distance.
But it's 150 meters per second, and we have T 30 maybe?
But we have the T to go from here to
Yeah,
here.
we don't have.
Yeah. So we need to work out this distance. Then we can know what this distance is. But of course, we need to know what the whole distance is first. So if we go back to the start, we can calculate the S. S equals U
That's half it.
T, or, yeah, we'll just go for the S to get to the top, yeah?
U plus V over 2.
Does that work?
Yeah, maybe that would be a little bit easier to use, yeah. So the S equals U plus V over 2, and the T to the top was 30.6.
Yes.
So that would be 150 times 30.6 I see, this is way too big. 4,590 meters.
We will not add the time, both times and
Hmm.
4,000?
Yeah, way too big. Maybe it's a sniper rifle or
Yeah.
something, yeah.
Okay.
Okay, so that's the distance at the top. Then we should get this distance here. So again, we'll do the S equals one. S equals, what was the U? 0. The V,
minus 150.
minus 150. And then the T, 15.29. So minus because it's going down. So now we can work out the remaining distance by taking away. So this one is 2296.5. Now we can use our formula. Time is distance over speed.
Okay, one second.
Yep.
How you got 150?
Where 150? This
Zero
150?
minus-
That was in the question.
Oh.
Yeah. So the last T is 15.31 seconds. That's the T for the last part. So we have this time, we have this time, and we have this time.
So we take the delta.
We add them. The sum, the sigma, if you want the latter. So the total time is 61.2 seconds. But I move this forward so it's not on the wall so much. Watch your laptop there. Displacement, which is distance. Okay. Yes, Mahmoud. I think that's okay.
This, the answer for 0 minus 150 over 2 is the below 15.29.
Did you just use Arabic?
What?
What's the word?
What?
What did you say again?
I said that 0 minus 150 over 2
Yeah.
multiply.
Multiply. I don't think you said multiply last
No, I
time.
said-
Is that something like
no,
or
no,
what's the
no,
Arabic for multiply? Okay, no, you didn't say that. Yeah. So yeah, 0 minus 150 over 2 times.
16.29.
Yes. Yes.
So I got the different answer from here.
Yeah, same here.
Oh, sorry. So I typed it in wrong, did I?
Well, it's minus 11.26. 0.75.
Okay, I'm sorry. Did you the same? You notice this as well? This is wrong.
Yeah.
Okay, what should it be?
11.46.
11
Minus.
minus 11.46.
Yeah, 0.75.
Okay, well then 47 then.
Okay.
Okay, so then that changes, of course, this answer. Yeah, so sorry, I'll fix that now. 4590 minus 1147. That leaves me with 3443. Sorry, so messy now. I'll write it here. 3443 over 150. So that's 23 seconds, basically.
Okay, this 3 this like.
That was the total minus the answer you gave me.
Oh, okay.
Yeah. Sorry, so it should have been 23, 30 and 15. So my time for the last part was wrong. So let me just re-add them. The tree, yeah, which one? This one was the total distance minus the 1147.
So it's minus 1147.
Yeah, let's not worry about the sign. So like we know the total
449.
distance is 4590. That's distance, 4590, and the other distance was 1147. So I just minus the 2.
So
You don't
just
have to
ignore the
do
minus.
that.
Yeah, because we're talking about distances.
Okay.
Yeah. 69 seconds. Yeah. What? Go and ask me. It's okay.
No, I'll ask about the displacement.
Yeah.
The rule
Yeah.
of displacement.
Yeah. Yeah? No, ask me.
Speed,
Yeah.
square speed over time.
You're
So
talking
S
about,
equal,
you want the formula?
yeah, the formula.
Okay, no problem. V equals U plus AT. V squared equals U squared plus 2AS. S equals UT plus a half AT squared, and S equals U plus V over 2T. This is what you
Yeah.
want. Okay. Take a picture, because I'm going to move on, okay? You know picture?
Yeah.
Photo? Instagram?
Snapchat.
Snapchat? Yeah.
WhatsApp.
Yeah. Yeah. Okay. Well, can we go to the next question? Yep. Okay. Right. What's the next one then?
A 1,200 kilogram car will accelerate to its top speed of 160
Okay.
kilometers per hour.
1,200 kilograms.
Accelerate to its maximum speed, 160 kilometers per hour.
Okay. 160. Okay. So this is its maximum speed is 160 kilometers per hour, and it starts at rest then. Okay.
Over 20 seconds.
And it took it 20 seconds to reach its maximum speed. Okie dokie.
What is the approximate drag force? Why is this only an approximate?
Good. Good. Okay, so what's happening here? At the beginning, there is a force driving the car forward. We'll call this F. And what's the drag force at the beginning? Zero. So we're good with that, okay? Then at the end, we still have our driving force, the thrust. And then is the drag force zero?
No.
No, it's not zero at the end. In fact, what is it at the end?
I think this is what
They will come together, right? The two cars.
Oh, no, there's only one car.
Oh, okay.
Yeah.
Is it minus?
It's not
Sorry.
animation.
Yeah. No, it's not yet. Does anyone know what this will be? At the end. The drag force at the end.
It would equal the first,
Yes. Why?
because the car is going faster. So there is a bigger force.
Oh,
Because the car
you're doing so well.
The car reached it faster.
Yes, but why does that make it the same?
Because
It will
it
be-
reach the limit.
Yeah, but why does that mean it has to be the same?
Because the car can't go fast or something.
No.
Or
The drag must equal the thrust because it's not accelerating. So the forces must be balanced. Just like with our parachute man.
Yeah.
It's the same, okay? So it has to be an F here. Yeah? Okay. So here's our problem. When the car is accelerating, there's a driving force forward, which we call F. But what do we use for the drag force in our formula? Do we use 0? Or do we use F? Or do we use something else? No. See, now what do we do? So if you remember last time, what did I suggest we could do? Do you remember? I suggested we could use the average drag force. The average drag force. Because the drag force is changing, isn't it?
So we don't know it specifically.
We don't know it specifically. We know that at the beginning it's 0, and at the end it's F.
Mhm.
But we don't know in between. So we can use an average. So what should I use then? If you think about this. It starts at 0, it finishes at F, so what's the average?
so it will be
F upon
120 over 160.
Nope.
F upon 2.
Yeah.
F over 2.
Yeah,
The last
F
one.
plus 0.
Yeah,
Yeah.
0 plus F over 2. So this is like the average drag. Right, so now we can say UVATS. We'll have to do some converting.
Yeah.
Have you got that convert already? Yeah, what is the U? Oh, what's 0, sorry, yeah. The V,
V V is 44.44.
Okay. The A we would like to know, and the T is 20. V equals U plus AT?
Yeah.
Yep. 44.4 equals 20T. So what's that? 2.22? No. Yeah.
That's 2.22. Yeah.
No, hang on. Sorry, I'm being stupid.
It's A.
Sorry, wait, that's
it's
A, yeah.
You'll find A.
20A. So A is 2.22.
Yeah.
Now we don't want the A, but we need the A, but we don't want it. What do we need? What did I want? I wanted the drag force, wasn't it?
Yeah.
Was it? Or what did I ask for
So
exactly?
what is the approximate drag force?
Yeah. So this here is what we want. We want this.
Yeah, so we multiply the acceleration by the mass and divide it by.
Yeah, well, we say F equals ma, but remember this F is the total F. So what's the total F here? It'll be F minus F over 2. Because it's this minus this one.
Yeah.
And what's the M? 1200. And what's the A? 2.22. So we can get F over 2, which is actually what we want, funny enough, is equal to this. So that's the average drag. That's not the drag all the time, because at the beginning it's 0 and at the end it's more. But on average the drag is of this size. So this is the answer. Okay, so this is difficult. I know, this is difficult. Did anybody get it? How far did you get, Mir, for example?
At the end, it's the F minus F upon 2. I did it.
So
right in the 2F plus ND. I went through it.
Yeah, this was a key step then, yeah.
This was the step that I missed.
Yeah. So what to do about the drag? Okay. Is there one more part, or one more question, I mean?
Yeah.
Yes.
Yeah, okay.
Can we
Yeah, oh yes, definitely.
Mr. Steve,
Yeah.
in this course, are we going to talk about the electronegativity?
The electronics? Electricity?
No, electro.
Negativity.
That's chemistry.
It's
That's chemistry.
No, there is on physics.
I know, yeah, it's not electronegativity. Electromagnetic.
Yeah, electromagnetic.
Yes, we'll do that, yeah.
And
Yeah, go on.
electron.
Electricity, circuits.
Yeah.
Yes.
Spectrum. He's talking about that.
No, you mean the circuit?
Not the test.
Oh,
He's talking about the
Oh,
alpha,
the-
beta, gamma.
the-
Which chapter?
the radiation, alpha, beta, gamma, yes.
And greenhouse and
Greenhouse, no, not greenhouse. But alpha, beta, gamma, radiation, yeah.
and the greenhouse. Yeah.
Greenhouse?
How about the black body?
Black body? No, we don't do black body.
For this semester or the second semester?
Ever.
Or year?
Ever, yeah. We don't do black
So,
body.
what are we?
So yeah, if you're curious, it's mechanics, which we're doing now.
Yeah.
The next topic is electricity. The next topic we'll do, I think we'll do waves.
Lambda.
Yeah, that's it, yeah. Then we have electromagnetic fields. We have materials, like heat. Yeah, and finally atoms.
But atoms, this is in chemistry.
Yeah, but we have a different look at
So
atoms.
this is the plan.
So, yeah, so in chemistry your atoms are about chemical bonds,
I
electronegativity.
think that chemistry is like little hard or something.
Oh no, you're wrong, it's very hard. It's not a little hard, it's very hard.
But the teacher
Okay.
is good. She's good.
Yeah, it's a tough course.
Everything is good.
She's the best teacher.
She's the best.
Like, she's the best chemistry teacher I've ever got.
Yeah, chemistry teachers can be weird. Your chemist, I'm picturing your chemistry teacher in school being an old man.
My chemistry
Yeah,
teacher was the
usually
best.
like-
Yeah, usually, yeah. Big belly.
Yeah, and the
Yeah.
teacher stuck him.
Yeah.
My chemistry
It's
teacher.
normal.
My chemistry teacher had the national award from the country. He was.
Oh, great.
He was a PhD.
Oh, great, that's
He
great.
was the best.
Yeah.
The way he taught me organic chemistry and these everything, I can't,
It was fantastic.
it was fantastic.
Good. Okay, number 3, yeah?
Question.
Yes.
how about the orbit? Like we calculate from Earth to orbit.
Yep,
G,
yep, that's in,
times M2
yes,
or 2.
yes, that is in semester 2.
Yeah.
Yeah, okay.
You have to wait for a while.
You'll have to wait, yeah, if you stay, you can see it, yeah. Right, what's number 4?
10 gram ball bearing.
Yep. Yep, ball bearing, yep.
It's dropped into a 1 meter tall beaker of water.
Okay, so let me just draw that, sorry, 10 grams, so that's 0.01 kilograms, and this is 1 meter, yep.
A second identical ball bearing is dropping into an identical but empty beaker.
Yeah.
The first ball bearing takes 10% longer to reach the bottom of the beaker.
Ooh, yeah.
Approximately what was the drag force experienced by the first ball?
Nice. Yeah, I think of difficult questions sometimes. And this is a difficult one. Did anyone feel like they got it?
I don't know, I'm right or wrong.
You got something, yeah. So,
I think this
Yeah?
is an idea.
yes.
Like we, can you give me a minute?
I think we'll find the weight and then we'll, take the 10%.
Yeah, like this.
Divide it.
What we'll do first, what happens is this ball is dropped in an empty container, and this one's dropped in water, and it takes it 10% longer to drop. So, in fact, it might even be more than 10%, I just picked 10%. So what's happened here, we'll get the time for this one first. Might as well do that. So U, 0, V, we don't know. The A is minus 9.81, the T is what we want, and the S is minus 1. So what will we use here?
So the question is when
S is
around
equal to half
bottom-
AT square.
Yeah.
S is equal to half AT square.
The S equals UT one, is it? Yeah. So that's 0, yeah, plus a half a T squared. Oh, and the S, sorry, is minus 1. So we can easily solve that. Minus 1 times minus 2 divided by 9.81 with a square root. And it's a small number, as it should be. The T equals 0.4515, we'll say, seconds. Okay, so now if I look at this situation, we know that the time here will be 10% more.
Oh.
So we know that the time will be 0.4967 seconds. That's an extra 10%. How do you increase the number by 10%? A quick way to do it.
multiply.
Yep. That gets you 10%, and then you would have to add it on.
Yeah.
Like this, like this.
No, we will multiply by 10
No. You see,
upon 100.
No. So. If you have a number, whatever, 560, and you want to increase it by 10%, the quickest way to do that is just multiply it by 1.10. That will increase it by 10%. Yes? Yes. And if you want to decrease it by 10%, be 0.90.
Yes.
Yeah. So, here is the time increased by 10%. Okay. Now let's talk about the drag force. So, at the beginning, what's the drag force? 0. And the driving force is the weight. At the end, we still have a weight. And what's the drag force here?
0.
Now you see, this is interesting because in the question I never said that the ball reached terminal velocity. You don't know that it stopped accelerating as it hits the bottom, you know. So we don't actually know what it is, so I'll need to call it something like D. Because we don't know. We don't necessarily know that they're equal. With the parachuter, we knew that they were equal because I said in the question it's moving at a constant speed as it goes down. I didn't say that here. We don't know that this happened. Okay, so we have the D then. So on average, there's a W, and on average, what's going up? D over 2. That's like the average drag. Yeah. And is that what I'm looking for? I forget. What do I want?
Yes.
We
What
want the
was
drag.
the drag force experienced by the first ball?
Yeah. So I'm looking for the average then. Yeah.
D over
Yeah.
2 is the pulling force.
Yeah, which we call drag.
And
Yeah.
W is
Driving force, which we call
Yeah.
thrust. Yeah. Okay, so let's have a look then. We could, we know the T, we know the U, and we know the S. So we could easily get the A. What can I use to get the A now?
This
V.
is equal to UT plus half at square.
It's the same again, isn't it? S
V
equals UT plus a half A. No, sorry. Oh.
We want the A.
Sorry, I was being stupid. A half A T squared.
Yeah.
Okay, so the A, let's calculate it now. Minus 1 times 2 divided by 0.4967 squared. So the A, not surprisingly, is negative, but it won't be as big as minus 9.81 because of the water. It would be smaller. It would be minus 8.107 meters per second squared.
Why is it small?
Because the water, it's not falling as freely. It
Yeah.
doesn't have the minus 9.81. It has a reduced.
Have you ever played a game? We
Increasing.
put the coin and there is a box there and you have to put the coin in the box, but it never goes.
Oh, yeah. Yeah, yeah. I've seen that one. Yeah.
There was G like 9.81,
Yep.
and now there is G and the water, so.
No, well, here it is G. Here it's not G. It's some other acceleration. And I know it'll be smaller than G because it won't fall as quickly. It's not accelerating as fast.
Yeah, this is my point.
Yeah.
So it should be less. Or
It is less. G is 9.81 and this is 8.1. We agree, but you seem confused.
Because it's in minus, maybe.
It might as well because it's gone down. No? You look so confused. What's your question?
like it was 9.81,
Yeah, here it was 9.81. Correct.
and now there is the water, which also makes it like harder to.
Correct. Agreed, yeah. True.
Why is the G like?
What?
Because there is water, that's why.
Yeah,
If it's falling freely without water, it's
I
like.
know. I'm saying like it should be more, not less, because of the water.
It should be less.
It should be less.
The water,
Why
if
is
you
it
fire a gun in the water, it will slow down.
Decay,
The speed will slow down.
Yeah.
Oh, yeah.
Yeah. Are you sure it's okay?
Yeah.
Okay, fine. Right, so we have the... It's okay?
Yeah.
Okay, fine. So we have the acceleration now. So we could use Newton's second law that says force equals ma. But again, this is the total force. So what's the total force here? D over 2 minus W. Yeah? So D over 2 minus W equals ma. So D over 2 equals W, which is mg, plus ma. So the answer, now what did we say the m was? 0.01. And the g is 9.81. And yeah. It's not so big. 0.179 newtons is the average drag force. Yeah.
Could you please go?
Yeah, like this.
Yeah, that's fine.
Well, this is the whole question here. So on the right was without water, and on the left then was with water. Then.
everything is similar, but the letters like G, S, it's different.
They're probably like this for you, is it?
No.
This is my version of Arabic.
Like U,
Yeah.
we think DI.
Yeah, V initial and V final.
Yeah, and the S, we put a D, capital D.
Capital D.
Yeah,
Okay.
replacement.
fine, that's okay.
Small d, like a display.
You said capital.
No,
Small d, yeah.
Yeah.
I hope you at least use T. And A?
Yeah, the same.
Okay. Right, yeah. All right. Do you have this? Is there more on this worksheet, or is that it?
That's it.
Okay, I
That's
just
it.
take a picture.
Okay. Well, it's recorded as well. So, what was the other lesson? There was two, wasn't there? Simple force, was it? Yeah, it was just force, wasn't it? Yeah. Okay. Right. Can I close? No. It'll be uploaded. Don't worry, though.
I don't like it.
No.
I
Why not?
like
Okay, fine. Okay. Yes. Right.